Swayam Prabha. Digital India. Educated India.
Currently, we are studying about the conventional abrasive processes, wherein till now we have seen the grinding process. Now we proceed to few other conventional abrasive processes like honing, lapping, and super finishing, dragging, vibratory finishing, sandblasting, and so on. Few more are there which are not listed. So we will see all these processes one by one. Okay. So currently in this particular class, what we deal with is the honing process, introduction to the honing, what is a hone, which is a honing tool, and types of corrections, the manual and power stroke honing processes, honing mechanism, how the mechanism work, lubricants in the honing process, or the cutting fluids that are used in the honing process, and applications of honing in which sectors like automobile sector, other sectors, where are the sectors it is commonly used in the manufacturing industry. So the manufacturing cost, as you go on for the surface roughness requirements, assume that I want the low surface roughness. That means that the cost of the manufacturing will goes up. So if you see in the manufacturing sector, the roughness values, if the roughness values are reducing, that means that my RA value, average surface roughness value, if RA value goes down, cost, that is cost will goes up. Okay, I am just representing in terms of, to represent the cost of that particular process will goes up. As you see, normally the turning will give the roughness in between approximately from 7 microns to approximately 15 microns. Okay, and the cost is moderate, or if you want to go still further, you can go for the grinding process, but the cost, manufacturing cost will escalates up. And if you are going for the super finishing or honing or lapping processes, the cost still increases further. And nowadays, if you see, if you are going for the advanced abrasive finishing processes like abrasive flow finishing, magnetorheological finishing, and other processes, the cost of the product escalates very high. That means that the requirement of surface roughness, if it is the roughness value is low, as you go low and low of the surface roughness value, the cost will goes up. Okay, so that one of the processes that the cost is escalating is the honing process, which we are going to see in the today's class. What is the honing process? If you see the figure here, basically this is an engine cylinder, and which is honed by the honing process. Normally the engine cylinders will have cylinder liners and other things. Normally whatever you are going to do the finishing here is not the exact cylinder nowadays. If you will have a engine cylinder liners and you do it, because if the liners are goes damaged or it is erodes away, or and if it is abrades away, then what will happen? Then you will go for a new liner by keeping the engine safe. The honing is a low velocity abrading process in which the stock is removed from a metallic or a non-metal surface by bonded abrasive sticks. Okay, so this will have abrasive sticks. We will see in the upcoming slides. If the finishing operation is carried out not only to produce high surface finish, but also to correct the out of roundness, taper, and axial distortions in the workpiece. What are the things that one can correct using the honing process? We will see in this one. That's what I want to say is, on a honing process can not only produce the surface finish required, it also corrects the out of roundness, taper, axial distortion, as well as it generate some crosshatch patterns. Okay. So, we will see what all these things in the upcoming slides. The honing machine, honing operation can be performed in a drill press or in a lathe. Normally, you can have a dedicated honing process setup itself. If you do not have, then in the circumstances you can go for fixing the hone, which is a honing tool in a lathe or drilling press, and you can provide a rotary and reciprocating motions simultaneously so that you can do the required work. The honing process, basically it is an abrasive process where abrasive sticks are there. On 6 abrasive particles are held, and these abrasive particles will remove the material by abrasion action. You have seen the 2D abrasion, 3D abrasion and all those things. Similarly, the abrasion action takes place here. The small amount of material is removed by the honing stones or the sticks. The honing sticks will look like this, wherein you have abrasive particles like this. Okay. So, these abrasive particles will remove the material, mainly internal holes. Normally, as you have seen in the previous slide, it will be used for internal boring, internal surface corrections as well as internal surface finish applications. You can see the tool which is used in the honing is called hone. Okay. So, the honing head with honing stones made of abrasive material, adjustable sealed pushing springs. Normally, this will have springs, spring loaded things and other things, depend on type of abrasive sticks they are using, type of mechanisms they are using in a hone and other things. Okay. The honing tool that normally uses is nothing but a hone. If you see here, the abrasive particles are held on the sticks normally, and these abrasive particles will try to remove the workpiece material by abrasion action. Coming to the introduction of this honing process, it is one of the conventional finishing processes in which tool is called hone. As you have seen in the previous slide, the hone is nothing but the honing tool, which carries the combined rotary and reciprocating motion while the workpiece does not have any motion. In that circumstances, what will happen? The hone, assume that this is the hone, it will have rotary motion, it will rotate like this, as well as it will reciprocate also, because of which what will happen? It will have a helical motion while going and converts helical motion while coming, because of which there will be a crosshatch patterns. When going, it will go like this, while coming it will come like this. So, because of this, if you take a particular region, what will have you will have a crosshatch patterns. The honing stones are held against the workpiece, which is controlled the light pressure. Normally, the spring loaded or mechanisms or these other mechanisms are there. So, these will held the abrasive sticks to the workpiece. The honing head is not guided externally, but instead it floats in the hole being guided by the workpiece. Normally, it is our controlled internally, depend on the bore size and other things. These are the spring loaded or some other mechanisms are used so that it will go and stand on the surface, or it will go and sit on the surface. Whenever you try to give reciprocation as well as rotary motions, it will start upbraiding the workpiece material. It is desired that the honing stones should not leave the work surface. At the same time, stroke length must cover the entire work length. Normally, the reciprocation motion, that is the axial motion or the axial motion that the honing stick or the hone has to perform should be throughout the work length. Various honing stones, normally if you see, these are the single one where you have only single honing stone is there and it will try to abrade the workpiece. And the workpiece is here and the guide shoe is there and the mandrel and other supporting systems for the abrasive stick is there. So, multi-point contact uses similarly the basic problem with this single point is the single stick is that the material removal rate is very less. At the same time, there may be a vibrations because one side you are removing a material. Assume that you are removing a material in this side, you do not have any other thing on other side. So, because of which there may be chances of slight vibrations. So, this is their chances are there that it is not compulsory that there will be vibrations. There are chances. For that purpose, normally people what they will go use is multiple type. So they can use on opposite sides, because of which what will happen if there is any vibrational effect or in a micro to nano regions, so it can counter. Okay, that's why people may also go for multiple types depend on their application. This will increases the material removal rate. It will increases the material removal rate, but in the case one, like single stick horns, the material removal rate is very less. So what all it can do? It removes the stock, that is the workpiece material, and generating the exact bore tolerances. Normally whatever the exact requirements are there, it will give those tolerances. It can do the polishing of a bore and finishing bore almost materials such as spray coatings, ceramics, compared to alloys and metals and other things it will do. It can correct many of the things like barreling, bell mouth, boring marks. Assume that if you see here in this particular region, what will happen? You will get a boring marks like this. Boring, it is like a turning process internally in a hollow cylinder. Okay, these things and tandem, others out of roundness. Normally out of roundness is the, if you see with the naked eye, everything looks perfect circle, but if you see in a out of roundness machine, normally the surface looks like this. Okay, if you plot a minimum diameter, what is you can do, and the maximum diameter, the distance between this one is out of roundness, so you can correct it or you can minimize it. Rainbow effect, at the same time reamer marks. Now if you see here, the reamer marks are there. Normally reamers will have this type of marks, so you can correct it by the abrasive sticks that are there on the horn. On the taper, huge taper is there, so you can correct the taper, but you have to play with the input parameters such that the material removal is approximately minimal, because in the taper condition, what will happen if you are going to give the same thing here, what will happen if you give harsh input conditions, there may be chance of failure of the horn. That is nothing but the honing tool. Undersize, if you want to resize it to requirement, you can do. And waviness, there will be some correction it has to do to a perfect cylindrical structure, you can do. These are corrections that one can do using the honing process. That's why it has a huge applications in the many industries such as automobile, energy sector and other things. Methods of honing. So one is a manual stroking method, another one is power stroking method. Normally manual stroking methods are used for whenever the tolerances are requirement is very high or you need precise tolerances. Other thing is that you can, some of the things that you can go for is experienced people will be there in the staff, or the experienced staff will be there. So they will do, even though you are using a power stroke method, so you may not get as per the requirement because it is automatically done. So if there is any fine things that has to done, if you have to do the fine corrections or ultra fine corrections, then the final touch will be done by the manual stroking with a experienced staff. Okay. If you see the power stroking, it is used for mass production of small parts, and this is economical because if at all I want to make a single component in thousands or lakhs of pieces, then just you load the work pieces and you do the power stroking method of honing process. So that will economical, and if at all you require a customized product, always you have to go for manual stroking method with a experienced staff. If you see manual stroking method, this type of things you can use in the manual one. So manual one, people will use the drill type of things they will use. If you can see here, the operator is using a drill type of thing, and manually he hold, whenever he is giving a rotational motion, then he himself has to give reciprocation motion with respect to hand. That is most mandatory, because here the portable drill machine can give only the rotary motion, it cannot give reciprocation motion. In that circumstances, the manually the operator has to give the reciprocation motion, so that you can execute both the motions like rotary as well as reciprocatory, and this is called as manual stroking things. It is called as manual stroke honing process. So, power stroke honing tools, if you see here, these are the how the power stroke honing tool look like, and this is a schematic. Okay. So, you can see the honing sticks are the stones, these are the stones where assume that these are the stones where abrasives are embedded, and it can be done by a commercial machines. Okay. These are the commercial machines. Once what you have to do is you have to load the workpiece, this is the workpiece, and this is the power stroking method. Okay. So, you can incorporate all the necessities and just you switch on, it will do its own function. Okay. This is called the power stroke honing process, and these are the things, these are the two tools which are used in the power stroke honing process. The factors affecting the honing, if you see the factors, one is the raw material, that is the workpiece material, and machine controls, machine structure, honing stones. I can say these are the input parameters, number of strokes, what is the pressure that you want to give, what is the feed rate, stroke length, rotational speed, reciprocating speed. These are the input conditions that normally the operator put on the machine. Apart from it, the honing stones also, the wear, bonding, material, hardness, grit size, these are all the deciding factors of the surface finish that on the component which you want. Okay. If the grit size is very high, assume that my abrasive particle size is very high, the surface roughness that I am going to get is also very high. RA value will increase. That means that abrasive particle size increases, its interaction or the material removal is increases, at the depth it can create will increase, and other things. Okay. So, where if it is the abrasive particle, you have seen the grinding wheel specification. So, there the particle size, bonding material, soft bonding, hard bonding, or open structure, closed structure, these are also play a major role here, but there the grinding wheel is a complete system, but here these grinding strips are there. Strips are held to a hone, that is nothing but a honing tool. So, these strips also follow the same similar grind, I cannot say exact same, but similar grinding specification. Honing process mechanisms, the cylindricity, material removal rate, honing trajectory is primarily determined the 5 groups of factors. The group 1, which is machine tool, second one is a honing head, third one is structure and material properties of the cylinder, fourth one is honing process parameters, and fifth one is the effect of initial cylindricity, that is nothing but initial conditions of the workpiece and other things. Okay. So, we will elaborate all these things in a next slides. So, the first one which will affect is the machine tool, which is the fixture, stiffness, dynamic characteristics, like how the machine tool is fabricated, whether it is the normally machine tools are made up of cast iron, so that it can have the damping effects. At the same time, it will capture the vibrations if there is, and also because the cast iron will have more amount of carbon in terms of graphite, and graphite will have this type of damping effect. Okay. The fixtures, you have to choose the fixture such a way that it should hold the workpiece firmly, and the stiffness of these sticks as well as other things to be taken care in the machine tool. The second one is the honing head structure. Normally arrangement of honing stones, material properties of honing stones, which is a grain size, density of honing stone, that how many abrasive particles are there for a unit area, material properties of honing stone, and other things. Okay. So, the both head structure and arrangement affect the honing trajectory. Okay, how the helical path is going, how many helical paths you have to generate. If I want few, so my abrasive particles are few on my strip is required. If I want more, I have to go for more. And thus affect the cylindricity of the engine cylinder bore. That means that material selection, grain size, density of the honing stones have great influence on the material removal rate. That means that the grain size, I said if the grain size is large, what will happen? The material removal rate will be high. If the density is very high, the material removal rate will be very high. Okay. So, these are all play a major role in the material removal. The third one is structure and material property of the cylinder. So, these have to show impact on the material removal rate by means of changing the contact stiffness of the honing stone against the engine cylinder bore. Okay. If the structure is not proper, what will happen? The variation will come on the pressures. So, this workpiece also play a major role. If the shape is like this, then it has, whenever it is on the periphery, assume that I have like this a surface. Whenever my hone sticks are touching here, the pressure will be different. Touching here, the pressure will be different. Okay. So, you should be careful about the shape, size and other things in the size of the workpiece. Okay. So, other things like taper or some other things, as you can see here, if the shape is like this, so the pressure distribution will be very difficult. Okay. If the taper is like this, what will happen? The load at the bottom will be very high compared to on the top. Okay. For this purpose, there are different varieties of honing processes are there. Those are called flexible honing processes. We will see at the end of this particular class what is flexible honing and other things. The fourth one talks about honing process parameters, that is the honing speed, feed rate, honing pressure, changing overall acceleration, overrunning distance and other things. You can see these have significant influence on the cylindricity by changing the honing trajectory, material removal rate and contact stiffness. These aspects fully considered because these are the primary requisites or primary things that one has to take care, because these are the input conditions the operator going to feed to the machine if it is a power stroke method. The fifth one is effect of initial cylindricity previously generated by the boring operation. Normally, the boring operated workpiece will be done the honing process. In that circumstances, what will happen? Your cylindrical boring which was done generally is assumed to be perfectly geometrical feature before performing a honing process. What we assume that whatever the component that received for the honing process to be done is a perfectly done by the previous process. In this particular case, what I am assuming is it is a boring process is done before honing process and it is perfectly done, but always this is an assumption, because most of the time this may be an assumption because there may be some of the errors, sometimes the surface may be altered and other things. Okay. For that purpose, what is required is you have to consider the practical situation of the honing process also, whether it is done the boring process, whether it is done a internal grinding process or some other process. Okay. You should be taken care that also whenever you want to achieve the better surface finish, better material removal properties, better other metallurgical properties and other things. For that, you have to also consider the initial surface roughness and other things. If I want a surface roughness of 0.5 micrometers, if my pre-machined surface is 10 microns, I cannot get it. It will be hard to get because you have to go by multiple honing processes using multiple honing type of sticks from coarse to fine to super fine and other things. Okay. So, what I mean to say is that if at all I want to achieve certain things, the initial surface roughness and the structure will play a major role. Honing process mechanics, if you see the honing process mechanics, it is having, as I said, rotary motion, reciprocation motion, honing stones which are spring loaded, and if you do this one, what is happening? This will be reciprocating, as I said, this will be rotating. In that circumstances, what will happen? You will get a crosshatch pattern. This crosshatch pattern, that means that it is not only generating a good surface roughness, but also it generates surface pattern or texture. This also gives you required structure. Why you require this crosshatch pattern? Normally, if you see the engine cylinders, these engine cylinders are in olden days, I mean to say, if you go back 20 years back, whenever you go to a petrol shop or whenever you want to fill, they will fill the petrol, along with that they will also fill a lubricating oil in that one. So, whenever the petrol which is mixed with the lubricating oil goes to your engine cylinder, that is the piston region, what will happen? This lubricating oil will stay in the crosshatch patterns. If there is a crosshatch pattern, deep crosshatch pattern, what will happen? It will stay in the lubricating oil will stay in the crosshatch pattern, and it will support the less wear of the piston, because the piston has to reciprocate like this. So, it will support the life of the piston. For that purpose, not only the surface finish, you also need a pattern, surface pattern. The honing process, various motions, if you see the two speeds combined together, what will have, how these are the generated in a conventional way. Previously the gear systems, if you see the rotary motion, this is the input is given here. So, the gears are, these are the two gears which are rotating, this intermittent gears, and this intermittent gear will rotate the another gear, and this will have a connecting motion here, and this will in turn rotate this gear system, and this is how, this is the hone. The rotary motion will come. At the same time, this is the hydraulic controlling unit where you will reciprocate, for which now you got the rotary motion as well as reciprocating motion. This is how you will get, or the people used to fabricate the rotary as well as reciprocating motions in the honing process. Whenever you have a rotary and reciprocating motions, what will happen? Whenever you have a rotary and reciprocating motions, you will have those forces as well as velocities. Okay. So, this is axial direction. Normally, you will have a axial force. This will, if you have the abrasive stick will be there, then you will have a radial force, and you will also will have axial velocity, and radial velocity normally it will be very minimal. Okay. For that purpose, you will have a resultant force, which is nothing but it comes from the FR and FA. Okay. Here something is written. Some people they say that instead of axial force and axial velocity, people also say that tangential force and tangential velocity in some of the textbooks. Okay. So, since this is normally people will call in the radial only, because it is intersecting or it is upbraiding against the wall. So, always it will have a radial effect. That is why it is called radial force, and the velocity at which it is indenting inside the workpiece is very less compared to your axial velocity. In that circumstances, what I can say is your radial velocity is much less than your axial velocity or your tangential velocity. For that purpose, your radial velocity is neglected. Honing surface roughness, if you see the surface roughness, oscillating speed, rotating speed, resulting cutting speed and inclined angle, Normally lay is nothing but the surface pattern or predominant direction of the surface roughness. In this particular honing process, lay is nothing but the crosshatch patterns. And as you can see, this is a cylinder liner, and you can see particularly the surface here. Okay, this is having a crosshatch patterns like this, and at the same time when it is coming up, it will have a crosshatch patterns like this. So this is nothing but the crosshatch patterns where the lubricating fluid will stay in these red lines, and the surface roughness of the other region is very good. The crosshatch angle depends on the ratio of reciprocating speed with respect to the rotational speed. If the reciprocating speed and rotating speed is approximately equal, then you will get a 90 degrees. So the tan alpha, which is the crosshatch angle, reciprocating speed and rotating speed, you can calculate with respect to tan alpha. You can get, if the value is get, then you just do the tan inverse, then you will get the alpha value. So honing process and applications, normally cylinder liners. If you see here, as I was telling you previously also, the technology is growing. Previously people used to do the engine cylinder itself, and if the life of that engine cylinder goes off, what will happen if it is abrades off after doing multiple times the honing process, then you have to throw the complete engine cylinder itself. So it is not a feasible solution. For that purpose, people goes nowadays with respect to the cylinder liners. This is called the cylinder, and this is called cylinder liner. Okay. So what is the advantage of this one? If your cylinder liner is gone off, then you replace with new cylinder liner, so that your engine complete block will be saved. Okay, these are the some of the cylinder liners that you can see here, and this is once you do the press fitting normally, and then you do the polishing using the honing process, so that the fitting will be perfectly fine. So honing process types, as I said, these are the conventional one is a rigid one, or you can say there is no much flexibility. For that purpose, as I said, no, there is a bell mouth, some taper and other things are there. For that purpose, if you have a waviness type of surfaces, in that circumstances, whatever you want to do is you need to go for some of the flexible honing systems. In this you can use it. Instead of rigid sticks, you are going for a flexible ball type which are connected to the strings. Okay, you will see in the next what is this flexible honing. As you can see here, the flexible honing, these are the wires that are connected, and these are the balls. Normally these are made up of polymer, sometimes the glue. This is a combination of materials are used, many varieties of materials are used which are patented technologies. Thankful for the Google from where I bought it, these pictures, and these are all will be used for the finishing applications. If you have a shape change, normally if you see the dimensions are here is this much, whenever you see the dimension is this much, in between the dimension is changing. In these circumstances, if you clearly see here the width it is occupying is this much, but in the other case this is this much. So this flexibility is there in this particular process, but in a rigid process this flexibility may not be, because the spring loading things can hold. If this is the minimum, it will hold only minimum. This is the this much only it will hold. It cannot hold the second region. Okay, this is the second region, this is the first region. It will hold only the first region. That's why the flexibility is there in this process. That's since this flexibility is there, this is called the flexible honing process. Flexible honing, normally hone tools, you can see the flexible honing tool is a perfect solution for many finishing and deburring application. You can also use for the deburring application. Deburring means if you have a drilled hole, on the edges you will have burrs. That means that remaining materials in terms of undetached chips. These undetached chips also can be removed by this type of flexible hone tools. Okay. Available in variety of sizes, as you can see here, a variety from ranging small to medium to very large. Okay, these are the things are there which you can get the superior finishing. Flexible toning honing are unlikely any other honing tool because it is produces unmatched control surface, because the surface finish here you are going to get is better surface finish compared to the normal rigid surface finish. So, the flexible honing versus rigid honing, instead of 2 or 3 stones in a rigid honing, we can have a smaller stones that are flexible. You can have the 360 degrees. That means that if you are going to have 3 or 2, what will happen? If you have 2, you have to go for 180 degrees, 180 degrees. If it is 3, 120 degrees, 120 degrees, 120 degrees, 3 you can have. In the flexible, what will happen? You can go for complete 360 degrees, so that you can do a better uniform surface finish, and very little pressure on the thin walls, because modulus of nylon filament. Basically, some of the companies they will make nylon filaments and the other things. So, the load is very flexible. It is not too rigid like a rigid one. So, the surface finish that you are going to get is better, and the hone is self-centering and self-aligning. As you have seen in the previous one, the dimensions are changing. If the dimensions are changing, what will happen? It will align by its own because of the size change. It can go bigger diameter, it can contract in the smaller diameter and other things. You can cut off the old surface and present a new surface with the proper ring seating and oil retention without targeting deal material removal. Okay. So, you can even get the good material removal as well as good surface finish also in this particular process. If you see the rigid honing, it is the scratch is very deep scratch. The scratch is very deep here. At the same time, the surface roughness is very random. The texture is very random. But in this case, you will have a very fine surface roughness with respect to the rigid honing process. Cutting fluids, normally the cutting fluids people uses in this one will be like lubricating, because the abrasion is the dominating factor and the temperature generation will be very minute, or I cannot say minute, it is medium, because the speeds that you operate is very less compared to the grinding process and other processes. That is why the lubricating phenomena of the cutting fluid is required. That is why you will always use the lubricating oil. As you can see here in the figure 1, so which is a lubricating oil directly using without any use of water in it, and at the same time you can also see in the flexible honing also the people are using directly the undiluted cutting fluids. Undiluted cutting fluids which have potentially lubricating characteristics. The cutting fluid, normally cutting fluids in the honing process performs the following important functions. It promotes the cutting action by flushing. Normally the generating particles are there from the workpiece, at the same time there is a fracture in the abrasive particles, and all these things will be flushed, and carries away heat, because the heat, the lubricating property decreases the friction, because of which what will happen? Heat generation is very less. If there is a generation, what will happen? By virtue of convective heat transfer, it will take away the heat and provides a lubricating action also. Okay, by which what will happen? The surface finish that you will get is better. A good honing fluid must have active at the normal temperature and must not corrode anything. Okay, at the same time, it should be instantaneously become active at the temperatures close to the melting points of workpiece material to be machined. If the temperatures are going high and high, what will happen in terms of engine cylinders and other things, the temperatures, if you are going very high, what will happen? It may reach to the temporary melting point of that particular cylinder material or cylinder liner materials. So, at that time the cutting fluid which is having lubricating characteristics as well as cooling characteristics, it should become more active and do the needful. High temperature micro spots at the point of cutting action would result in this, in which the welding of the metal guide shoes and metal being honed. Okay, what will happen? Whenever there is a high temperature is there, then there will be a burst which will be welding to the surface. It won't happen if you are going to use the cutting fluids. Buffers like animal oils like nanolin, lard oil are often added as the honing fluids. These buffer oils minimizes or prevent the chatter of the honing stones and thus promote the tool life. That means that some of the buffer will add to the cutting fluids so that the chattering will not takes place. Both oil and water based with proper blend will be normally used. Whenever your people want to use for the economic purpose, then they can go for the oil and water, so that you will have a cooling property as well as a lubricating property, which we have studied in the cutting fluids in the grinding. The benefits: the prevention of wearing and tear of the workpiece, the maximum cutting rate can be achieved, excellent flushing will be achieved, low viscosity and excellent wetting will be always preferred in the honing process, because the viscosity is very high. What will happen? The flowability is very low. So, viscosity should be low. At the same time, wetting characteristics will be good. Wetting characteristics which we have studied in the previous class in the grinding fluids, where with respect to contact angle and other things, where super hydrophobic liquid, super hydrophilic liquid. If it is a philic liquid, what will happen? The wettability will be very good. Reduce the drag out, low order and low misting. That means that the fumes should be very less. This is the misting because of the rotation as well as the temperature. There will be a particles generation, there will be a fumes generation. This should be very less and increases the stone life. The basic fundamental importance of this cutting fluids which are using in a honing process should reduce the tool wear, that means the hone wear, and increases the life. Coming to the honing applications, if you see the hydraulics like axial, pistons, pumps, valves, cylinders and other things are used, and the energy productions like windmills, turbines, other things, also these particular things are used because their very high rotational speed is required, so that there should not be any wear. For that purpose, lubrication plays a major role. So, you need a crosshatch pattern. If there is a crosshatch pattern, lubricant stays in the crosshatch pattern, that is a deep scratches along with the surface, and it will improve the life. The other application is aviation, which is leading to the landing gears, turbines and jet fans and the blades, control shafts and other things. People will use this honing process. And the applications, most of the applications goes to the automobile sector, which is like motor blocks, small engine injectors, turbo, brake drums, many other applications are used in the automobile sector, and injection molding system, and other thing is that construction of the machinery like gears. Wherever there is a relative motion is there, piston, cylinder motions are mostly used there. This type of honing process is a mandatory. For a basic example is, if you take any bike, whenever you are sitting middle of this bike, assume that Hero Honda motor bike is there, Splendor or something. Whenever you put your legs in between, there is a engine cylinder wherein the piston, there you can see the fins and other things that normally honed by the honing process only. The honing process, which is improves the geometrical accuracy and setting the certain surface pattern, that is for the lubrication in the piston cylinder interaction regions, and the same material like grinding stones like silicon carbide, CBN, these type of tools will be used, and more precise shape, smaller grains. Always, if you saw the first slide of this class where you have started about the surface finish requirements are moving towards left and the cost is escalating up. Why? The surface finish that you are going to get is very good in the honing process. That for that purpose, always you should go for very minimal size of abrasive particles. If the size of abrasive particle is very less, the indentation will be very less. So, that means that the surface roughness that you are going to get is low. That means surface finish you are going to get is very high. The cutting fluids are used for the lubricating purpose. Basically, dominating lubricating characteristics are there, so that the so that the heat won't be generated first, then the tool life, that is the whole life, will be enhanced greatly. Expensive and time consuming, this is another disadvantage you can say, or you need to have some patience, because it is a time consuming process, because the material removal rate is very low, because it is a fine finishing operation among the conventional finishing processes. That is why the material removal rate is very low whenever you are going for correcting some certain surfaces. Okay, coming to the summary of this particular class, which we have seen introduction to the honing process and a honing tool which is called as a hone. We can see the power stroke as well as manual stroke hones, and type of corrections like bell mouth, taper and other things corrections which we have done. Manual and power stroke honing, which manual is used for final corrections and power stroke is economical for the variety of mass productions, like same operation for many of workpieces. Then the power stroke honing is good. The honing mechanism, we have seen the 5 factors that are affecting, and lubricating lubricants in the honing process and other things we have seen. Okay, then came to the applications of the honing process. These are all we have seen in today's class, and thank you for your kind attention, and we will see few more conventional abrasive processes in the upcoming classes. Then we will move on to the advanced abrasive finishing processes. Thank you.